Welcome to the lecture, guys. In this lecture we are going to discuss the basics of the graph. So we are starting the lecture series on the graph from the kinematics. My name is Anmol Kumar. I am MTech in Aerospace Engineering from Indian Institute of Science Bangalore and your instructor at iitpathshala.com. You guys can call me and can text me on the following number. You can give free examination on my site. Let us start with the lecture itself. So what we are going to study under these graph sections over here, we are going to study position versus time graph. We are going to study velocity versus time graph. Now these two portions are more important for the NEET and the mains point of view. Whereas the third one, acceleration versus time graph, it is more commonly asked in advanced and kvpy. Why are we even studying this? The question is very much clear to you guys. Okay, I hope you can comprehend the following question by the following diagram. You guys should be taking notes and you must watch the video till the end. Please watch my previous videos on kinematics, part 1 and part 2. First part will be covering the concept of motion in a straight line. The concept is along with numericals. The numerical are ranging from beginner level to hard level. Then there is motion under gravity, my part 2 of the kinematics, and again there is certain derivation, concepts and numerical associated with the topic. Now let us start the topic with the basics over here. So in this lecture we are going to cover the basics of the graph. Now guys, as you know that I can represent the Cartesian coordinate system as follow by my y-x plane. So this is my y-axis, this is my x-axis. Now I have made an arbitrary curve over here which is y equal to fx. Fine with that? Now in this session of the basics we are concerned about the slope and area under the curve. So what is a slope? Slope of a curve is not just an angle, it is the tan value of that angle. So generally people say that okay, theta is the slope, but no, theta is not the slope. Slope is tan of that angle. Now how you guys are going to find the slope of the falling curve over here? You have to consider a particular point. Let us say this is my point of interest, which is P. Then you are going to draw a tangent at this point. Let us say this is my tangent. Represent this tangent by a certain line, saying that this is my line L1. Then what you are going to do? Make a line parallel to this x-axis which is intersecting this line L1. So what I'm going to do is I'm making this line in the blue color over here. So this is my line number 2. It is parallel to my x-axis. Now whatsoever angle you are getting in between these two lines L1 and L2 will give you the angle of these line, and taking the tan of the angle gives you the slope. Fine with that? This is the slope. Now this value of tan theta is very much important, because if your tan theta is positive then you can say that okay, my curve is increasing, and if your tan theta is negative then you can say that okay, my curve is decreasing. As you can see over here, this is the point P, point of interest. Let us have another point which I am saying that it is my point Q. So this is my point Q. As you can see, if I make a line along this point, okay, if I make a tangent along this point Q, this is my tangent. I am naming this tangent line as L3, and if I take the angle in between this tangent line 3 and my x-axis, this will be my angle. Let us say that this is my angle 2. Taking the tan of this angle as tan theta 2, I will be getting a negative value. So as you can see, at the point P, my angle was acute, the tan value of that angle was positive, and from the diagram it is evident that the curve was increasing. But at the point Q, as you can see that the tangent, which is my line 3, is making an angle theta 2 with the x-axis over here, or a line, let us say L4, which is parallel to the x-axis over here. The angle in between the line L3 and L4 is theta 2, and this theta 2, taking the tan of this theta 2, is coming out to be negative. So I can say that there is an obtuse angle over here and my curve is decreasing over here. From the diagram it is evident. Now let us talk about area under the curve. So how you guys are going to find the area under the curve? First, let us take the analogy of a rectangle. So this is my rectangle. The length is P, the width is Q, the area is P dot Q, P into Q, P multiplied by Q, length multiplied by width. Fine with that? So now this is your curve. As you can see it on the screen, what I'm going to do is I'm taking a small strip over here which is having a width of dx. Now I'm taking the length as y. Now as I've given you that the length of the curve is nothing but y, and y is equal to f of x. That y is nothing but a function of x. So area will be equal to y into dx. Now what you guys are going to do is you are going to add up all the strips. This is first strip. You are going to add this strip number 2, strip number 3, then strip number 4, and have some more strips over here. Let us name this strip as strip number 5, this strip as strip number 6. You are going to add all these. So what you are going to do? You are going to use the basic principle of integration. So you are going to integrate, or you are going to add up all the strip as follow: y into dx from the point A to the point B, from the point A to the point B. Fine with that? You are going to add all these strips. So as you can see over here, y can be replaced by fx because I have given you that. Okay, y is a function of fx. This is dx. You are using the principle of definite integral. Okay, now the limits are given to you that at point A the value of x is x1, this is your x1, and at point B the value of x is x2. Fine with that? So after calculating this definite integral, you will be getting your area under the curve. Let us solve this problem to clarify our doubts over here and to apply whatsoever we have studied of area under the curve. So here you have to find the area under the particular curve y equal to 7x in between the 2 point P1 17, P2 214. So here as you can see, 1 is representing your x coordinate and 7 is representing your y coordinate. So this is x1 y1, P2 is representing your x2 and y2. So you can write your area as y of dx limit from a to b, as you can see over here. So y is represented as 7x over here. So 7x dx. Now your variable over here, as you can see, is x. So I'm varying my limit from a to b is from 1 to 2 in the form of x-axis only, in the form of x only, which is the basic principle of definite integral. So as you can see, I am varying from x equal to 1 to x equal to 2. So after integrating 7x, I am remaining with 7x square by 2 over here. And I am going from 1 to 2. I am going from 1 to 2. Replace the limit as follow and you will be landing up with your answer over here. Now let us study the graphs. So first one is the straight line curves, which we are going to deal first. Okay, so as you can see that I can represent my straight line by the general equation y equal to mx plus c, where my m is represent the slope or your tan theta, c represent the intercept on the y axis. Now guys, point to be noted that the angle theta which I am calculating with respect to my x-axis of my line, let us say L, is acute or it can be obtuse as follow. So this is the acute angle and this is the obtuse angle. Now you should be noting that the c equal to 0, if your intercept is equal to 0, the line will pass through the origin. Okay, it will simply pass through the origin. If y is equal to c, then your line will be parallel to your x-axis as follow. Okay, here it is representing y equal to constant itself. Okay, so y equal to a certain value, let us say 7. Okay, so the graph will be something like this. Okay, y is having a value of 7. Okay, now if you are having the case of x equal to c, then what you will be saying that, okay, in the case of y equal to c, I was having a line parallel to my x-axis. In the case of x equal to c, I will be having a line parallel to the y-axis as follow, as you can see over here. Okay, now let us move how to draw y equal to mx plus c. First 3 points to be noted that first you have to find the slope. Then observe your slope whether it is acute or obtuse. Let us have the following example over here. Y equal to minus 3x plus 2. As you can see, my slope is negative over here. Okay, so I can certainly say that my slope is coming out to be negative, so angle will be obtuse itself. Fine with that? Then you have to find the intercepts. How you will be going to find the intercept? Now let me tell you what are the intercept. Intercepts are the points which are cutting at the y-axis and the x-axis itself. Okay, these are called the intercepts. Point cutting on the y-axis or the point cutting on the x-axis are the intercept. Now if you want to find the intercept on the y-axis, you should be putting your x equal to 0. For example, in this case y equal to minus 3x plus 2. If I want to find the y axis intercept, this point over here, what I can do this, as I know that on this line, this is my y axis, my x will be equal to 0. So I will be simply putting my x equal to 0 and I will be remaining with minus 30 plus 2 equal to plus 2. So this is my point of y equal to 2. Fine with that? Now if you want to find x-axis intercept, what you will be doing, you will be simply putting your y equal to 0 itself, because this is the line of y equal to 0. So after putting y equal to 0, I am having my x as 2 by 3. So this is the value of x at this point. Fine with that? Just put y equal to 0. Now what you will be going to do, you are having your point as point number 1, this one, point number 2, this one, join both of them by a straight line. As you can see, I am having an obtuse angle over here, which verifies that my angle is coming out to be an obtuse angle, the slope is negative and my answer is correct. Fine with that? Now draw the graph for the following equation, 2y equal to 3x plus 2. Remember that in this equation the slope is coming out to be a positive, so I can say that the slope is acute. You must be reducing this equation in the form of y equal to mx plus c. As you can see, how I did that was just to simply divide this particular equation by a value of 2. So 3 equal to 2 upon 2y equal to 3 upon 2x plus 2 upon 2. Y equal to 3 by 2x plus 1. So that's how I was getting my slope as 3 by 2. Then you should be finding out the intercept. So just make a table over here, x and y. So when you are having your x as 0, you'll be having y as 1. So just put x equal to 0 over here in the following equation, y equal to 3 by 2x plus 1, and you'll be having y at x equal to 0 equal to 1 only. Y 3 by 2, 0 plus 1, giving you a y value of 1. Now to find the intercept on the x-axis, just put the y to be equal to 0. Okay, so after putting y equal to 0 in the following equation, you will be having the value of x equal to minus 2 by 3. Fine with that? So your graph will be coming something like this, that you are having the x-intercept as minus 2 by 3, your y-intercept as positive 1, join both of them. As you can see, after joining both of them, the angle I am having here is acute angle, and it is evident from my positive slope over here. Now let us solve the particular question over here, which is most frequently asked in NEET examination and your JEE examination. Okay, so here as you can see, v versus x curve is given to you, but we are going to study about position versus time, velocity versus time, and acceleration versus time graph. But in this graph, as you can see, the graph is in between the velocity versus the displacement itself, and he wants you to find the acceleration of the particle at x equal to 3 meter. So how you guys are going to deal with this? First, we are going to use the basic maths, then we are going to transit from the basic maths to the physics aspect of that problem itself. So as you have studied the straight line concept of the graph, you can reduce this graph into a straight line. You can deduce the straight line formula or the straight line equation of this particular graph as follow. As you know, your intercepts are given to you. This is point 1, this is point 2. You should be remembering that the coordinates are 2, 10 of the point 1 and the coordinates of point 2 are 6, 8. Okay, so as I can make a equation over here, v equal to mx plus c, where m is my slope, c is my intercept. Fine with that. Now you are given with the value of v and x over here, and you are unknown with the value of slope and intercept. Okay, if you got the value of slope, as you know, if you got the value of slope, what you can do, you can just simply apply the physics aspect of the problem itself, which we will deal later in this question. First, what you should be doing is, you should be remembering this equation and you should be finding the value of this equation itself. So as I can replace the point over here in this equation, I will be having v over here, as you can see, is 10. So 10 equal to the value of x is 2, m into 2 plus c. So this is my first equation. Second equation will be nothing but 8 equal to, as you can see, the value of y or the value of v over here is 8 equal to m into 6, the value of x is 6 plus c. This is my equation number 2. Now using the elimination formula which you have studied in the 9th class or the 5th class, you can have the value of m and c from these two equations over here. Okay, so I am just subtracting equation first from the second itself, and I am remaining with 2 equal to minus of 4m. So I am having the value of my tan theta as minus 1 by 2, and it is evident from the graph that the angle is obtuse angle. So henceforth I am getting a negative slope over here. Okay, now what you are going to do is, you are going to find the value of c. Just replace the value of m in any of the following equations. So I am replacing the value of m in the first equation itself, and I am having the value of c as 11. Fine with that. So my value of c is coming out to be 11. So my resultant equation over here becomes v equal to x minus 1 by 2 plus 11. This is the resultant equation which I am getting. Now I want to find the acceleration of the particle at x equal to 3 meter. I know that I can write acceleration as v dv by dx itself. Now from the formula of acceleration itself, what I can say that at x equal to 3 I want to find the answer. So my values will be only at x equal to 3 itself. Fine with that. So here I know the value of velocity. This is the equation of velocity which I am getting. Just I can replace the value of x as 3 over here, and I can have the value of v equal to at x equal to 3. I can have the value of v at x equal to 3 just by replacing the x over here as 3. So v equal to 3 minus 1 by 2 plus 11. So you are going to have the answer as plus 9.5. Fine with that. Now what you are going to do is, you must be finding out this value dv by dx. As you know that in the following curve v versus x, dv by dx is nothing but the slope of my curve, which I find it out in the equation itself by the following elimination method. It is coming out to be minus 1 by 2. So I can just replace all the values over here. 9.5 multiply dv by dx, which is coming out to be minus 1 by 2 over here, which is coming out to be minus 9.5 by 2. So this is the value of acceleration for me. Okay, and you should be remembering the SI unit, meter per second square. Now let us study about parabola. So the general equation of parabola can be written as follow: y equal to ax square plus bx plus c, where your a, b and c are the constant. Now you cannot have your a to be equal to 0, because if your a is 0, then you are landing up with the equation of the straight line itself, which is y equal to bx plus c, where b will be representing your slope and c will be representing your intercept, as we have studied in the previous slides also. Now guys, as you can see over here that I've made two faces over here. First one is the smiling up face, second one is the sad face over here. Now from the equation itself, y equal to ax square plus bx plus c, if you are having a greater than 0, then you are having an parabola which is opening in the upward direction, which is represented by a smiling face over here. So if your a is greater than 0, then you are having this kind of parabola. Let us make the axis system over here as follows. So this is my xy axis, this is my y axis, this is my x axis, and this is the origin itself. So this is the parabola which I will be getting if my a is greater than 0. Now if I'm having my a to be less than 0, then I will be having a sad parabola. Then if I make a line over here, my axis system xy as follow, then you can say that this is the origin of the xy system, and I am having a parabola over here which is representing a sad face itself. Now let us talk about the intercept, which is c of the following equation, y equal to ax square plus bx plus c. So as you can see, if my c is equal to 0, then my parabola will be going through the origin itself, okay, because y equal to 4x square plus 3x, as you can see over here, my a is positive over here, is also representing a parabola, but here my c value is 0. Now if you put the point x equal to 0, y equal to 0, you are landing up with the equation of 0 equal to 4 into 0 plus 3 into 0, which is equal to 0 itself. So 0 will be equal to 0. Henceforth I can say that at point 0 0 this parabola is passing through origin because it is satisfying the 0 0 condition itself. Fine with that? So at c equal to 0, my parabola must be passing through the origin itself, whether it is smiling up parabola or it is smiling down parabola. So guys, I hope that you loved my lecture, liked my lecture. Please give it a thumbs up. I have made this lecture only for you guys, so this will become your strength in your examination. Now from this onward, we have studied about the basics. Now we'll be getting into the deeper and the advanced detail of all the curves, position versus time, velocity versus time, and the acceleration versus time, securing your precious marks into the examination. You guys can contact me, you guys can give examination. I am 24/7 available for you guys. So we'll meet you in the next lecture guys. Until then, goodbye.